This radical equation is a little bit more complicated than the last ones we've looked at. What complicates it is the fact that we have two terms that are outside of the radical expression. Our approach remains the same. We will isolate the radical expression on one side of the equation. I would need to get rid of this minus 5 in order to isolate the radical expression here. So I'll do that. I'll add 5 to both sides of the equation. Our equation now becomes x plus 5 equals the square root of 4x plus 17. Now we can square both sides of the equation to remove the radicand from the radical. When we square the right side of the equation, we are simply going to get the radicand, 4x plus 17. Now, we need to be careful over here. Remember, don't make the obvious mistake. When you square a binomial, that's really multiplying the binomial times itself, which is our friend FOIL. And so if we think of this, this is really going to be x plus 5 times x plus 5, which is going to give us x squared plus 5x plus 5x more, which is plus 10x plus 25. We squared that binomial. And now we recognize we have a quadratic equation. So let's put this quadratic equation in standard form. I'll do that by subtracting 4x and subtracting 17 from both sides. So that's what I was going to do, then didn't do it. Once again, this trinomial looks relatively simple. Since the coefficient of the squared term is just 1, I'm going to give it a shot to see if it's factorable before I try solving it using the quadratic formula. And indeed, I chose it so that it was factorable just to speed things up. Won't necessarily do that for you on a test. This factorization of these two binomials would give us that trinomial. And now we know our two solutions to the equation are x equals negative 4, x equals negative 2. This again was a radical equation. We need to check these solutions in the original equation to make sure they work. They may not work. If they don't work, we have to throw them out and say that that solution has no, that equation has no solution. So let's try first the solution of x being negative 4. So we'd have negative 4 equals the square root of 4 times negative 4 plus 17 minus 5. So that's going to be negative 4 equals the square root of negative 16 plus 17 minus 5. Negative 4 equals square root of 1 minus 5. And the square root of 1 is 1. And indeed, that's true, isn't it? Negative 4 equals 1 minus 5. So that solution was good. That solution is a valid solution. It's not an extraneous solution. Now let's try negative 2. And again, when we substitute negative 2 for x, we find that this solution works as well. Negative 2 indeed is equal to 3 minus 5. So both of our solutions are legitimate solutions to this radical equation.